This particular topic is relevant to just about anyone who has a smartphone or a smartwatch or anyone who is using the Internet of Things and the ability to gather data, learn from that data, and perhaps ultimately solve some health problems along the way. So I'd like to introduce you right now to two individuals. First, we have Mayank Goel. He is with Carnegie Mellon University School of Computer Science. Hi, Mayank. How are you?
Hi, Steph. I'm doing good. How are you?
Good, thank you. You work in a lot of different capacities at CMU. Tell me all the different areas that you're working right now.
Yeah, so I'm a associate professor here in the School of Computer Science, and I work on using machine learning and sensing for helping people live a healthy life. We use the sensors and other technology that is there on our phones, fitness trackers, wearables, Internet of Things to identify how people are living their lives, how is their behavior changing their body, and how the changes in their body or their physiology is affecting their behavior. And we keep looking at that cycle over and over again to learn how the person's body and their behaviors are linked together. And we use that to help people identify illnesses before they go to the doctor. We help them take care of themselves at home, and we also help the doctors make a decision when they are trying to uh, help a patient manage their illnesses.
You also spend some of your time putting this into practice at the Smash Lab. What is the Smash Lab?
Yeah, so our lab, SMASH Lab, stands for Smart Sensing for Humans. And so we basically work on problems that we humans face in our daily lives. And with health being a main focus, uh, we spend a lot of time on that, but at the same time we work on a lot of other things. For example, accessibility, building technologies for resource constrained environments such as sub-Saharan Africa, South Asian countries, and other resource constrained populations within uh, uh, North America as well.
I can't wait to dive into this. I want to introduce into the conversation now Traci Kennedy. Traci, you are with the University of Pittsburgh and a clinical psychologist. What is your interest in this particular topic?
Yeah, hi. So I am a researcher and I study ADHD. And in particular, I'm really interested in helping young people with ADHD and their families to make life better, to make life easier while managing ADHD. And I'm really interested in how to bring in support for ADHD in the moment over the course of individuals' day-to-day lives. And so that has gotten me really interested in the use of technology and learning more about how we can leverage tools like passive sensing to be able to figure out when those moments are that support is needed throughout the day and in different contexts. So that's what has gotten me interested in this work and brought me to this project.
We're calling this data from humans. And it's interesting, Traci, that you bring up specifically passive sensing. Let me go back to Mayank. Mayank, what is passive sensing?
So passive sensing basically means that you are able to sense things about a human without the human's involvement or without the active involvement of the human. So one of the examples there would be looking at a person's step count. Now, step count, the number of steps we take in a day, is information that almost all devices that we have on ourselves these days are able to record, whether it's our phone, fitness tracker, smartwatch, smart rings, shoes, eyeglasses, any smart device can record the number of steps we take. So that's a passive information that we can record about a human. And from that information, we can learn a lot about a person. So, for example, we can figure out if a child is physically hyperactive or how their physical hyperactivity is changing over time. We can identify depression symptoms in people. We can identify anxiety disorders in teenage girls, etc.
I would imagine that there would be truth in the data when it's collective passively because you're not actively reporting. I look at a food log where maybe you're getting it right, maybe you're not, you're making decisions, whereas passive is just simply the absorption of the data. Do you find that
Mhm.
there's truth in that data?
There is truth, but it's very noisy. So, for example, many researchers have shown that step count, I'll just use that example again, is can be up to 25% inaccurate. So there is a lot of noise in that information, but even that noisy step count is still useful in us learning a lot about our behaviors. So if we just wanted to see whether someone is walking more or less, we can figure that out from that information. But turns out that even more reliably, we can extract mental health behavior markers from that fairly noisy information. And that is one of the uh, research directions that my lab takes, that how do we use imperfect sensing? How do we use imperfect machine learning in the domains where we need perfection, where we need to strive for perfection, for example, healthcare?
Before I go back to Traci to talk about a couple of the avenues and research projects that she's working on, Mayank, I want to ask you if you find that what is the way that artificial intelligence, AI and ML, is actually helping you unpack this noisy data and make better sense of it?
Yeah, so as I said, right, like the data is noisy, but because we are able to collect a lot of data from each individual, because it is recorded passively, so we keep the burden on the user low. We make sure that we do not invade their privacy. So we are able to get a lot of data from each individual. And because the burden is low, we are able to replicate this for many people. So we have a lot of data. Then we can use the modern machine learning and artificial intelligence algorithms to help us figure out what are the markers that are resistant to the inherent noise of some of these passive sensors. And we are able to establish relationships between the person's physical behaviors with their mental health and their uh, overall psychology.
Traci, Mayank is doing the research that is establishing the protocols, the best practices, and then delivering effectively products and apps and software, and in some cases, easy to use and deployable hardware for some of the other projects he's working on. But you're the end user. You're the person out there working directly with young adults and people trying to get ahead of this. Tell me how this works in your line of work specifically.
Yeah, so I think I am primarily a researcher, but I also work clinically with primarily young adults and teens with ADHD. So doing therapy to help them with managing ADHD in their everyday lives. From my researcher lens, the work that Mayank is doing is extremely valuable and interesting to think about how we can pull that into our current assessment techniques to understand, like, for example, in ADHD, how is ADHD looking over the course of individuals' daily lives? What are those changes look like over the day, across the week, in a reliable and meaningful way, so that we can get a better handle on what's actually happening, how that behavior is changing, than just asking individuals, because we are pretty bad reporters overall of our own behavior. I think in ADHD and also working with kids, there's a level of awareness there that especially the passive sensing can really help with. So using it as a research tool, I think, is extremely exciting. In terms of the direct clinical implications of something like this, I've talked with a lot of therapists and coaches and others who are working directly with young people, especially those with ADHD, and having some sort of data stream to be able to see, well, you reported you were doing these strategies on this day, and like, look what your data is showing. This is really useful. And then on this day, you mentioned you didn't get enough sleep, and we can see how this is really affecting your symptoms. So I think that interaction with the provider and giving some more of that real time data is really exciting too, to be able to help individuals have more insight and like change their behavior in a more day-to-day way than we're currently able to.
Mayank, your work has to be very rewarding when you see things that you have had put your thumbprint on actually have real world applications and make people healthier.
Oh, yeah, for sure, right? Like we strive for impact. We strive for making sure that the things we are working on have a promise of immediate impact. Now, frankly, that is a very high bar at times. So we do need to work with students to sort of figure out that we are not getting too bogged down by those expectations. The expectation is that you want to work on things that can potentially have that immediate impact. And then as you strive for it, there are going to be things that you are able to lead to fruition, that you are able to put it out into the hands of people. But that zeal, that like initial focus on making sure that you are working on things that have that promise is important.
Traci, when I was listening to you tell me about the work that you're doing and using data to help better counsel patients, the other thing that occurred to me too is you must be able to get some better information to make better diagnoses. So you are able to determine who clinically would benefit either from medication or cognitive behavioral therapy or other modalities that are available to treat ADHD versus kids who maybe don't need it, who had been misdiagnosed in the past. Tell me a little bit about what you're seeing in the space right now as someone who works on the front line with this.
Yeah, definitely. I think diagnosis and making some of those recommendations in terms of therapy, medication, for example, can be really complicated, and there's so much that needs to be taken into account. In ADHD, again, since that's what I focus on, a big piece of the puzzle is looking longitudinally, like in the past, over time, and when did these behaviors start to develop. And I think, parents and teachers and individuals are still going to be really critical in being able to provide that history and that timeline. The way I see diagnosis is sort of the more information and sort of like pieces of that puzzle we can connect, the better off we are to have that whole picture, to be able to make the best recommendations and the most accurate diagnosis. So I think part of where some of Mayank's type of work fits in with like an ADHD diagnosis would be sort of how much is this happening right now, and how quickly can we get that information to be able to get something started, whether that's a medication or some sort of therapy, and then be able to track the individual's response to that treatment in a really quick way. So one of the big problems with our current methods of self-report of behavior is that it just takes a long time to get ratings back on kids' behavior, whether that's from parents or teachers or both. And so being able to get that in real time can give us a much quicker answer to something like, is this child responding well to a medication that they're starting? And that can help overall with the diagnostic picture as well to understand, are we going in the right direction here?
Traci, what got you into this line of work and field of study?
That's a great question. I First of all, have been really interested in especially how behavior develops and children's behavior. When I was younger, I worked as a dance teacher and I worked with different levels, from preschool all the way up to teenagers. And I was just fascinated by seeing the differences and seeing how different influences in their lives sort of translates to their behavior. And so from there, I just jumped into psychology and learned a lot about developmental and clinical psychology. And I found it really fascinating. In graduate school, when I was getting trained in the clinical side of things, so therapy and assessment and diagnosis of mental health, I got especially intrigued by the differences I was seeing between more in the moment techniques or sort of real time support for individuals versus maybe a more standard approach of come into a therapist's office for 50 minutes once a week and then go off and do it. I think that model works really well for some people, but in other cases I was seeing, we really need more points of contact. We need to like infuse this person's environment and day-to-day life with that support that they need. I was seeing that in different settings, like hospital-based settings and inpatient settings, where they were getting that sort of real-time support. And as technology has developed, I've been intrigued by, how can we maybe not replace a therapist, but complement what they're doing with the technology that can be that support in a more real-time way for individuals. So that's what has kind of gotten me to where I am now.
As a mom, I love that it was the mayhem of kids dancing, little kids dancing, because I mean, anyone who's lived that life understands that got you here today. Mayank, I want to ask you, what was your journey? How did you find yourself in this line of work?
So I think my story is a bit boring than Tracy's. I've been a computer science student almost throughout my life. In high school, I knew I wanted to do computer science, and I didn't really have too many deviations. So, but at some point, I realized that we are working on a lot of things that can really help the society, that can help the humans. Um, so, at some point during my graduate studies, I realized that we need to start looking at problems where we can make a more direct contribution. Um, and during my PhD, we worked on a bunch of things. We focused on health. I worked on accessibility. I worked on technologies for resource constrained environments, and I've kept those interests. And I attract students who are interested in working on those problems as well. So we focus on all of these different avenues.
What was one of the first things you developed that you realized this is it? We've really created, you and your team have developed
Yeah.
that you realize you've created something special. What was that? What was that product, or go to market's not quite the right word, but what was the first research that you really accomplished something and you knew that you were on the right path?
Yeah, so we built a smartphone-based spirometer. So spirometer is a device that measures lung function or lung health. So we made a smartphone-based one where you just need the microphone that is there on every phone, because that's the basic purpose that a phone solves. It allows us to talk. So we just converted that phone into that microphone into a health sensor, and we tested it out with many people. We started with a study actually in Seattle at University of Washington, and then we took it to different countries. And I think that was the project that sort of proved to me that a lot of expertise that we had could be applied to something of societal impact.
So now we move into Lemur DX. What is it?
So Lemur DX is a passive sensing approach to identify physical hyperactivity symptoms in children. So we use the motion sensors and some of the other contextual sensors on a smartwatch to identify a child's behavior, to identify their physical hyperactivity levels, and we contextualize those physical activity levels with their behavior and context information to figure out if the activity levels that the child is exhibiting right now are these expected, or are they lower or higher than expectations. So for example, when our machine learning models tell us that the child is supposed to be reading in this moment, are they moving too much? Whereas if the sensors tell us that this is the time of the day or the location that the child is in is for soccer practice, then they are expected to be moving around. So adding that layer of context to a child's behavior, to a child's physical behavior, allows us to accurately identify hyperactivity symptoms. And more importantly, it provides the doctor a window into the child's life, so that when a teacher tells that the child is very hyperactive in my class, the doctor can look at the data that the watch collected to figure out that yes, the child is hyperactive in that class, that teacher is correct, but that hyperactivity level is not that high in other classes or is not high at home. So then instead of just working with the child, there is a possibility for the parents as well as the teachers and the society to sort of figure out how do we support this child at home and at school, and what are the strategies that are working in different contexts.
Are you required to have a baseline data set from children who are not diagnosed with ADHD to have something to compare it against? Or does ML AI help you get to the bottom of what should be considered baseline and normal? And how did you train for that?
Yeah, so we do have a population model. We collected data from children who did not have a hyperactivity diagnosis and children who had, and our model right now does a comparative study. Um, but we make sure that our algorithms are not biased. So we make sure that we have as many hyperactive children as non-hyperactive children. And right now we are running studies where we are working exclusively with children who have hyperactivity, but depending on whatever medications they might be taking or other behavioral therapies that they might be part of, how is that hyperactivity changing over time? So overall, the algorithm looks at comparison to expected levels of physical hyperactivity. But at the same time, for a child whose baseline for themselves is going to be a bit higher, we want to make sure that the algorithm is able to figure out what their individual fluctuations are over a period of time.
Were there any surprises so far as you started collecting this data, or did you find that it was um, perhaps as expected?
Frankly, the thing I was surprised by the most was that the children did not play with the smartwatch that much. The data we collected data from around 70 children. All of them were between the ages of 5 and 12. I can't believe that they did not break the smartwatch. Only one smartwatch was broken throughout the study. And they didn't delete the app, they didn't install new apps. I don't know who these children were. My children would not be like that.
Well, that's the computer scientist in you. You would have taken it apart and put it back together again and then uploaded your
Exactly.
own software on it.
Yeah.
I'll ask you both this, but Mayank, just to continue the conversation, I'll start with you. How do
Mhm.
you address the privacy concerns that may or may not be associated with the sort of research that you're doing?
Yeah, so we actively think about the privacy concerns of the data that we are collecting because we are collecting data about people's behavior and their body. This is as private as it gets. So we have to think of privacy on day one. So we make sure that the data we collect remains secure. That is the first part. And then the second is that the algorithms we build, we make sure that they do not rely on the private information. So for example, our algorithms do not record whether the person was at home or were they at school or at work. What we record is that the person spent what percentage of the time did the person spend at the place where they spend their daytime. So the information is obfuscated. For some of our mental health research work, we don't even record that is this a place where they spend their daytime. It's just that these are the three locations where they spend a considerable amount of time on a given day. What percentage of their time did they spend overall at these three locations? What percentage of their time did they spend at a fourth location? So that information is very obfuscated because when we build our models, we need all the information that is possible. So we work with people who consent to us to collect that data and we make sure it remains secure. But in the end, the algorithms we build, we ensure that those algorithms are not relying on overly private information.
Excellent. Traci, I noticed specifically as I was looking in your um, the studies tips, start smart, I believe those that
Mhm.
specifically I noticed consistently you're working with young adults, and that may in fact sort of dovetail off of what Mayank is saying in terms of consent and the ability to do the work you're doing. Talk to me a little bit about how you address privacy and concerns in the work that you're doing.
Yeah, that's a great question. There's a few answers, I'd say. One is we are doing a lot of work and conversations with the young adults we're working with, and sort of iteratively building up our research designs to ensure that we are not designing something that young people wouldn't feel comfortable with. So, for example, um, I've enjoyed talking a lot with our young people and both giving quantitative surveys to understand how comfortable would you be with various levels of passive sensing and the type of information we'd be collecting, but also just in one-on-one conversations. What are your concerns? What are you comfortable with? What scenarios would bother you in signing up for this research study? So we're really trying to understand that from the end users themselves so that we're designing the research and ultimately an end intervention or product that they would feel comfortable with. The other piece is that we do work very closely with IT at Pitt and with folks like Mayank and his teams to ensure that the data are being stored and transferred in the most secure possible ways so that we really are being good stewards of individuals' data, even if what we're extracting is the sort of least invasive possible. And I think lastly, one important thing we've learned in talking with young people is giving them the autonomy. So, if they no longer want to participate, they always have the option of withdrawing or honestly even turning off the app for the passive sensing if they feel like that's what they need at that time. So, really making them not only feel like they're in control, but actually being in control of that data.
Are you finding over time that society and the kids and the young adults that you're working with are becoming more accepting of giving that information? And what makes me think of this question is me being older versus my daughter and her willingness to share her location and have um, a much broader digital footprint than I was comfortable with for a while. So I'll ask both of you that. Traci, you first. Are you finding there's a different acceptance with younger adults than perhaps with some of the older folks maybe you've worked with?
I would say in general, yes. I think it's very nuanced, and I think it's very individual too. But there's a good bit of data out there now, and what we're finding in some of our work is that in this young adult age range, so let's say 18 to 25-year-olds, a generally bigger concern with this type of technology research or passive sensing research is that it'll drain their battery as opposed to some of the privacy concerns. And so it's not to say that privacy isn't an issue, but I think the relative concern is probably different in the younger generations.
Well, we've talked to some of the other CMU colleagues about using AI and ML to build a better battery, so maybe that's coming in the future. I say it in jest,
There
but
we
it is a
go.
very interesting point. Mayank, what are you seeing in the populations that you're working with? An acceptance of passive sensing data collection that's greater than it was before?
Overall, I would say that the acceptance of passive sensing has definitely increased, but it was always fairly high. People were Very few people were concerned about the passive data. But what we have seen is less and less people are getting concerned with active data collection as well. So, for example, putting microphones and cameras in people's home or using microphones and cameras on phones or on watches, the level of acceptance we are seeing is increasing. The level of comfort we see even from older adults. So we do some work with older adults who have skin cancer, and we ask them to record videos of them as they are taking care of themselves at home. And they don't have that many issues with that. Like, of course, you will find people who will be more concerned, but the people who show concern are on a completely different spectrum. So the nuance of concerns has sort of gone away, I feel, or is slowly going away. Like either you just don't trust technology or you are sort of like completely trusting. It's like getting into these two buckets.
What does AI and ML need to accomplish next, Mayank, in the space that you work in? Where do you see things going?
So I feel AI and ML need to have a better dialogue with the humans. So AI needs to help the humans and the humans need to help the AI. I think it has to go both ways. We can't wait for AI to be perfect, because that's a very, very high bar. We might not ever get there because humans are also not perfect, right? If someone tells us to do something, we just don't take that at face value and say that we'll do it. We have our own thought process that we apply to anything that we hear from humans. Same thing needs to be done with AI as well. So, for example, with all of the work that we are doing in the health area and even in the Lemur DX project, the goal is not to make a diagnosis. The goal is to help the doctor make a decision, and then also to help the parents navigate their child's condition. But at the same time, I think the humans have a role to play in improving the machine learning and improving the AI algorithms as well. That, hey, you were wrong there. The child is reading a book right now, they are not watching TV. Or you might think that the child is hyperactive, but no, they are not hyperactive right now. This is expected level of activity for this child. So it goes both ways.
How do you see wearable technology evolving over time?
I think we'll see wider acceptance of AI and ML. We'll see wider deployment and use of these technologies, and people will understand the limitations of the systems and will figure out how to navigate around the noise that technology has.
Thank you both for your time and perspective.
Thanks
Thank
so
you.
much.
You've been listening to Does Compute, the podcast that examines how computer science is building useful stuff that works. Thanks so much for joining us. I'm Steph Stricklen.